Alright, so we got tree growth. So a 1996 study examined the growth of grapefruit trees in Texas, determining the average trunk for trees of varying ages. Okay? So we got to fit a linear model to this data. Okay, then what concerns do we have about this model? Okay, so here's what the graph looks like. So there's obviously a curve in there. Okay? So let's see if we can straighten it. I'm going to try to go down the ladder of power. So I'm just going to go to log of L2. And then we're going to do plot L1 versus L3. And then we'll zoom that. And that obviously is not helping. Okay, so going down the ladder of powers did not help. Let's see if going up the ladder of powers will help. So let's do L2 squared. And I'm just going to push zoom 9, and obviously that's curved. So I'm not liking the ladder of powers right now. So I am going to go to my attack of the logarithm. So I'm going to do log of L1, and then I'm going to do log of L2, and I'm going to do L3 versus L4. Yeah, that's still curved, so this isn't there probably isn't a way to re-express this using a linear model. So I'm going to go to one of my models that's built into the calculator and see what that can do for me. So let's go take a look at this. Let's see. Alright, so that has two curves in it, right? It goes like that. So it's kind of S-shaped, so it looks like it might be cubic. So let's go and see if we can do a cubic regression. Alright, so there's the cubic regression. So the R squared value, I got to take a look at it first, but the R squared value is pretty high. It's like 99.9%. So 99.9% of the variation in diameter is being explained by age in this model, but it's average diameter. We'll talk about that in a second. So let's take a look, see what this looks like. Stat, vars, statistics, equation, regression equation. Graph that. Alright, so that worked. Alright, so it's not linear. So there isn't a linear model. We can't do a linear model, but we did use one of the models that was in the calculator. We used an exponential model. Okay, so that's the best we could do with that, so we re-expressed it as an exponential model. Okay, it had a very high R value. Okay, so not, like I said, 99.9% or almost 100% if you round it, of the variation in average diameter is being explained by age. So that's a pretty powerful model. Okay, now what's the deal with this? Well, here's the deal with this. Okay, anytime you use averages, then you lose variability. Okay, it really doesn't tell the true story. So the fact that you're using average diameter here is a problem. Okay, we generally don't like to use averages when we're making any kind of prediction on a scatter plot. Okay, so to answer question B, it says if the data had been given for individual trees instead of averages, what would we expect to happen? Well, we expect the model to be weaker because we'd have more variation. Okay, we'd expect the variation in the model to be more, and we would expect the fit of the model, okay, to be less beneficial. Okay, so that would be the answer to that.